All right, we are ready for section 2.7, graphing absolute value equations. First of all, you need to know that the graph of y equals the absolute value of x looks like a V shape. That's why I have all the V's there. The graph will look like a V shape. It could be an upwards V and it could be a downward V. First of all, the graph of y equals a times the absolute value of x minus h plus k has the following characteristics. First of all, the vertex is at the point hk. Now notice in the equation, we've got x minus h inside that absolute value, and down here for the vertex, it's positive h. So it's always going to be the opposite of what's inside that absolute value for h. But the k is going to be the same sign as what's outside the absolute value. Number two, a is the slope. Now I put that in quotes because it's not technically the slope, because one side of it is going to be the right slope. The other side of the V is going to be the opposite slope of the V shape. The graph is going to open up if a is positive, so a would have to be greater than 0, then you know that it's going to be an upward V. And the graph opens down if a is less than 0. So if a is negative, the graph is going to be a downward V. So let's graph this equation, and then we're going to state the vertex. We've got y equals the absolute value of x minus 2 plus 3. Now to start out with, the vertex is going to have the point. Now remember, since it's a negative 2 in here, the vertex is going to be at a positive 2 for the x, and the y is going to be whatever's out here. This is the k in the formula, so it's going to be positive 3. Okay, so it's only the opposite of what's inside the absolute value. So that's positive 2, y is positive 3. So let's start by graphing that point, 2, 3. Okay, we'll put a dot there. That's my vertex. Now again, think about definition of vertex. Vertex is the highest or lowest point on the graph. Now I know that this is going to be the lowest point, because if you look in the front of this absolute value, there's nothing there. But remember, if there's nothing there, that's got to be like a positive 1. So my slope, notice again I put it in quotation marks because it's not officially the slope, but the slope is 1 of this V graph. Okay, and since it's a positive 1, that means the V is going up, so this vertex is the lowermost point. Now think about slope. 1 is also known as 1 over 1. So from this point, what I'm going to do is I'm going to go up 1, right 1, because both of those ones are positive, so it's going to be up and to the right, and I'll do that a couple times. You can do that as many times as you want to. And then, because this is a V shape, this has to be a mirror image over on this side. So that's where I put slope in quotes, because it's really now on this side the opposite. It's going to be up 1, left 1, up 1, left 1, and you can do that as many times as you want. And then you're going to go ahead and connect those dots into a straight line, arrow on the end because this V goes on forever. You do the same thing on the right side, and again arrow because the V goes on forever. And that's how you graph an absolute value equation. Let's do another one. First of all, looking at this equation, I want to find the vertex. Okay? The vertex for this problem, think about inside the absolute value, it says plus 1, so the x of the vertex is going to be negative 1. And the y is the same sign as what's going on out here, so that's going to be negative 4. So my vertex is at negative 1, negative 4. So I'm going to start by graphing that point. And this time, my slope, I'm going to use m. I'm still leaving it in quotes because it's really not officially the slope. Slope of this V is negative 1/2. That means that this vertex is going to be my uppermost point, because this time the graph is going down because of the negative 1/2. Okay? So now think about negative 1/2. From this point, I would go down 1, right 2. New point. Down 1, right 2. And do that as many times as you feel necessary. And then again, starting up at the vertex, now I also have to go to the other side, down 1, left 2. Down 1, left 2. And again, down 1, left 2. And then we go ahead and we connect those. So now you can see that that V opens down. One more, just for good measure. First, let's start with the vertex. And again, think opposite of what's inside the absolute value. So my x of the vertex is negative 2. Y value is the same sign as what's outside the absolute value, so that's going to be positive 3. So I start by graphing at negative 2, 3. There's my first dot. And for this one, my unofficial slope is 2/3. That means the V is going up because it's a positive slope. So from here, I'm going to go up 2, right 3, and do that at least one more time. And then again, starting at the vertex, I need a mirror image on the other side, so it's going to be up 2 and to the left 3. Up 2 to the left 3 again. So then I connect those points, and I have my upward V absolute value equation graphed. Now let's go backwards. Let's write the equation of the graph. To start off with, I would probably figure out where is my vertex for this problem. Okay, so let's write down what is the vertex. Again, think bottommost or uppermost point. So this point right here is at 3, negative 2. So I'm going to go ahead and write this in. We've got the vertex is at 3, negative 2. Next, I want to find what's my unofficial slope. If you look, I'm going to go ahead and go from this point up to this other point that they gave us. And if I did that, I would have to go up 3, right 3. Okay, so that's going to be positive 3 over 3. Rise over run. And that actually is equal to 1. Okay? Because the V is opening up, I know that I'm going to be using the positive slope because of the upward direction. So now if I'm going to write the equation, we start with y equals, and remember A goes next, so that would be my slope, my unofficial slope, which would be 1, and then my absolute value, always an x here, and then it's opposite of the x value of the vertex, so it's going to be minus 3. Finish the absolute value, and then out here is the y of the vertex, and that's going to be minus 2. So that would be the equation of the graph that they gave us. And if you want to, this one you don't have to have here, so you could also write this as y equals the absolute value of x minus 3 minus 2. And that would be the equation of the graph they gave us. Word problem. A rainstorm begins as a drizzle, builds up to a heavy rain, and then drops back to a drizzle. The rate r in inches per hour at which it rains is given by that function, where t is the time in hours. The first thing we want to do is graph the function. Now notice for this problem, our graph, the x is actually the t in this equation, and the y is actually the r in this equation. Okay, so this is your t-axis, this is your r-axis. Okay, so to start out with, to graph, think about the vertex, and I'm just going to label this a v this time. The vertex is going to be at positive 1, positive 0.5. So let's start by graphing that point. Here's 1, and 0.5 is right there. Okay, and now the slope, the unofficial slope of this equation is negative 0.5. And I'm going to think of this in terms of rise over run. So that's really going to be like negative 1/2. So from here, I'm going to go down 1, right 2, put a point. Notice I'm staying in between two lines. Down 1, right 2. Okay? And then again, mirror image on the other side. Down 1, left 2. Down 1, left 2. Now we try to draw this graph as nice as we can. A ruler probably would be good, or I could use my line function. But this would be what that graph would look like. So now I need to answer a couple of questions. Now, if you think about this in terms of time, we're not going to go negative on the time. So I'm going to stay right here in this little hill, okay? I'm going to be looking at this hill right here of this graph. Because also think about it, we're not going to go to a negative rate. We're not going to go for a negative inches per hour because rain doesn't go negative inches, okay? So I'm just looking at this little hill right here. Think about it. How long does it actually rain? Okay? So if you look at along the t-axis here, it goes from 0 hours out to 2. So how long does it rain? It rains for 2 hours. Okay? And when is it raining the hardest? Well, that's going to be at our vertex because that's when it's the most inches per hour. That's when the rate is the highest. So when is it raining the hardest? Well, that's going to be 1 hour after when it started. Okay? So it'd be at 1 hour is when it is raining the hardest. And this concludes section 2.7.